Now we are going to discuss about multi-cylinder engine. So that different types of multi-cylinder engine are inline engine, radial engine, and V engine. So now you see the inline engine. So this is the inline engine. Here there are 4 cylinders. All the cylinders arranged one side of the crank. So this is a crank. This is a crank. The crank have different position. There are different positions are there, but all the cylinders are at one side of the crank. So this is inline engine. In case of radial engine, see here, this is a crank. This is a crank. There are number of cylinders. There are 3 cylinders are arranged radially. Hence it is radial engine, and this is V engine. This is V engine, 2 cylinders, cylinder 1 and cylinder 2. They are arranged in V shape. So this is V engine. Now we are going to discuss about inline engine, right? So this is 4-cylinder inline engine, cylinder 1, cylinder 2, cylinder 3, and cylinder 4. There are 4 cylinders. Now we need to balance. So each cylinder will produce unbalanced force, that is inertia force. This will produce inertia force that will act along this direction. Similarly, for this engine, there will be a inertia force that will act along this direction. Similarly, for cylinder 3, it will act along this direction. Cylinder 4. All 4 cylinders have a unbalanced force. They are acting along this direction. As we discussed in single cylinder, the unbalanced force, that inertia force is equal to, we know that is m omega square r cos theta plus cos 2 theta by n. So this will be the inertia force. So for different cylinder means you have to put the corresponding theta value and you can get the inertia force. Now this is divided into 2. One is primary unbalanced force, another one is secondary unbalanced force. So this is a primary unbalanced force. The difference between the primary unbalanced force and secondary unbalanced force is, here the angle is theta, here angle is 2 theta. Primary unbalanced force, there is no n, but here it is multiplied with 1 by n. So there are the difference. So while solving the problem, by solving for primary force, then you multiply, you take, instead of theta, you take 2 theta and multiply by 1 by n. That will give the secondary unbalanced force. So just by solving the primary force, but angle must be multiplied with 2 theta and divided by n, that will give the secondary force. So we are going to first solve for primary. From the primary, we are going to get the secondary force, right? Similarly, primary couple and secondary couple. In case of single cylinder engine, there is no couple because only one cylinder, one force. So we cannot consider the couple. Here, each cylinder is producing force. So there will be a couple, or at different planes. So there will be a couple. So due to primary force, there will be a couple. Due to secondary force, there is a couple. So now we are interested in calculating unbalanced primary force, secondary force, primary couple, secondary couple of all the 4 cylinders. Now, if you see the theta value, here it is horizontal. The crank is horizontal. So, or you take some angle. So that is equal to theta. So the angle difference between these two is 180 plus theta. It is almost opposite. 180 plus theta. The cylinder 3 also, see, almost same as the 2. That is 180 plus theta. The 4, if you see, these two are identical and the angle is theta. So this is a crank position. Now, how to draw table, that we will let us see. So here, since this force, the primary force, if you see the primary force, it is almost similar to the centrifugal force created by the crank. Now you take a crank like this. You take this is a center point about which it is rotating. This is a mass m, and this is a radius r. The angle is theta. Angular velocity is omega. Then what will be the centrifugal force? Centrifugal force is equal to m omega square r. This is centrifugal force. Direction is theta. Direction is theta. So if you take a force of m omega squared r at an angle theta, So this can be represented like this. This force can be represented like this. So almost we can compare this one with um, rotating mass. We can compare this one with the rotating mass of mass m, angle as to omega, radius r at an angle of theta. So we are going to solve just like what the procedure we followed in rotating masses, unbalanced rotating masses. The same procedure we are going to follow this also, right? If you want to represent this one, you can represent like this. You can represent like this. A force at an angle of theta, the force is m omega squared r. This is a vector representation of this one. The same way we are going to do this, right? Now, if you draw the forces and couples in table, we can do like this. The mass of each cylinder is the reciprocating mass is m. So m we are taking as a mass. Radius, all the cranks are having same radius. So radius is r. So this is centrifugal force. Actually, centrifugal force is m omega squared r. Since omega square is constant for all, we are taking only mr. So this is the centrifugal force divided by omega square. And we are taking reference plane here. Reference plane here. And this is L1, this is L2, this is L3, and this is L4. That is distance of the cylinder 1, 2, 3, 4. From the reference plane is L1, L2, L3, and L4. So now if you find the couple, force into distance. Force into distance. If you, the distance towards right is plus, towards left is minus. So MR, the distance is minus L1, minus L2, L3, and L4. These two are towards left. So minus. If you multiply the force and distance, you will get minus MR1, minus MR L2, and MR L3, MR L4. These are all the couples. If you see the angular position, this is taken as horizontal. So it is 0. Second cylinder is 180. It's just opposite. 180 plus 0. This is 180 plus 0. Third also 180 plus 0. Fourth is again 0 degree. We told in case of primary force, if angle is theta, secondary it is 2 theta. So we are taking double the value. 2 into 0, 0. 180 into 2, 360. 180 into 2, 360. Again it is 0. So this, by this table, we will be able to draw the primary couple polygon, secondary couple polygon, primary force polygon, and secondary force polygon. All those things we can draw. We can find the unbalanced force. Now we will discuss about one problem. A 4-cylinder inline engine. This is a 4-cylinder inline engine running at 2000 rpm. N is equal to 2000 rpm, having crank and connecting rod lengths of 60 millimeter. The crank length is 60 millimeter. What is 60 millimeter? R is equal to 60 millimeter. And connecting rod length L is equal to 240. And the mass of the reciprocating part of each cylinder is 2 kg. All are identical. So all the reciprocating mass have 2 kg. The cylinders are spaced at 160 millimeter apart. The distance between the each cylinder is 160. Between 1 and 2, 2 and 3, and 3 and 4. All are 160 millimeters. The crank appeared at 90-degree angle interval. So between the each crank, so if for example the first crank is 0 degree, means second is 90, third is 180, fourth is 270. That way it is connected. But the firing order of the engine is 1, 4, 2, 3. You know what is firing order? Actually, in engine there are 4 strokes. One is suction, then compression, then is power stroke, exhaust stroke. The firing will take place just before the power stroke, right? So firing order 1, 4, 2, 3 means the firing will take place first in cylinder 1. After that, it's not in order. It is coming to 4, then 2, then 3. This is the way the firing takes place. The what is the meaning is, if the cylinder 1 is 0 degree, the cylinder, this is the angular position of the crank of the cylinder 1. The firing order next to going to 4. Then after 90 degree, the cylinder 4 will come. That is the meaning. 4 will come, then 2 will come, then 3 will come. So the angle between 1 and 4 is 90. Then 1 and 2 is 180. 1 and 3 is 270 degree. So that is the meaning of the firing order, right? So the firing order will help to find the angular position of the different cylinders, right? We find the value of omega, that is 209, 2 pi n by 60. And we know the value of L and R. You can find the value of N. N is equal to L by R. That is 4. Now you draw the table. Now you draw the table. Already in the problem, it is given mass is equal to 2 kg. Radius of the crank is 60 millimeter. M or omega. From this we calculated omega. Omega we need not put because it is common to all. Now mass of each cylinder is 2 kg. All are identical. Similarly, radius 60 mm. It is given in meter, 0.06 meter. And centrifugal force m omega squared r. But here we are not taking omega square. Then m into r. So this is a value of centrifugal force. Now distance. We are taking this as a reference. And distance between each cylinder is 0.16. So this is a half. So this is 0.8. This is 0.8. This is 0.06. This is 0.06. If you take the distance from the reference plane, this is the cylinder 1 is at a distance of 0.24 meter. And 2 and 3 are 0.08 meters. And 4 is again 0.24 meter. So these are all L1, L2, L3 value. But this value is minus and this value is minus. And this value and this value are plus because right side. Now you put the value. For 1 it is minus 0.24. For 2 it is minus 0.08. 3 and 4 it is positive value. Now you multiply this term, this column and this column. This will give MRL. MRL. That is couple divided by omega square. You calculate these values. You multiply this column, this third and fourth column. And angle position. Already we have seen the first crank is taken as 0 degree, fourth is 90, third is 180, and fourth is 270 degree. If it is doubled, this will become 0. This is 360. This is for secondary position. So if you want to calculate the secondary couple and secondary force, you got to use the value of 2 theta. 360. 270 plus into 2, it is 540. That is equal to 180. That is 540 minus 360. That is equal to 180 degree. And this is also 180 degree. So this is the angular position of the secondary crank. Now we have to draw the polygon and you have to find the unbalanced forces. So what you have to do in this problem? You have to find the unbalanced primary and secondary forces and unbalanced primary and secondary couples. You have to find, right? Now we have to draw the polygon, force polygon and couple polygon, primary force polygon, primary couple polygon. Now, if you want to draw here, all the values are known. For centrifugal force polygon, these are the value you have to take. For couple polygon, these are the value you have to take. So we are interested in to find the unbalance for all the data are known. So no problem. You can start with the couple polygon or force polygon, whatever it be you can draw. First, we are starting with force polygon. You have to take the force and direction. You have to take. What is the force? You have to take the force. The first one is you can take any order, no problem. Any order you can take, no problem. If you take the first one, what is the direction? The force direction is this direction. This is a force direction. What is the crank angle? Crank angle is 0 degree. We are considering the primary forces and couples. So for primary crank angle, you have to take 0 degree. What is the force? It is 0.12. You take some appropriate scale. Because we are connecting the 0.12 kg meter into distance. So you take some suitable scale and you draw here. So 0.12. What's the direction? 0 degree. So horizontal, this one. Next you take the 4. What's the direction? 90 degree. Sorry, it is 180 degree. Sorry, the fourth one is 90 degree. It is 90 degree. That is upward direction. 90 degree. What is the force? It is 0.12. So it is mentioned here. Upward 0.12. The next one is 2. You take the 2. 2. What is the force? 0.12. What's the direction? 180 degree. 180 degree means here it is right towards right. That is towards left. So this is the mass 2. And now you take the mass 3. What is the force? 0.12. What is the direction? 270 degree. 270 degree means downward, right? So this one. If you draw this, you will get the couple is the polygon is closed. The force polygon is closed. What is the meaning? There is no unbalanced force. There is no unbalanced force. So as far as primary force is concerned, all are balanced completely. All are balanced completely. There are four forces created by four cylinders, but all are balanced properly. So there is no unbalanced primary force. Now we are going to see the primary couple. Primary couple. Here you have to take these values. MRL value. This is a couple value. For first cylinder, you take. First cylinder, you take. If for first cylinder, what is the direction? This is primary, right? It is 0 degree. Direction is this. Direction is this is a direction. But here the value is minus. So you have to take in opposite direction. You have to take it in opposite direction. How much it is? 0.0288. This is a starting point. Actually 0 degree, it should be taken towards right, but since the value is minus, you take in opposite direction. Opposite direction. Value is this and direction is towards left. Then you take the fourth one. You take the fourth one. What is the direction? Upward. But here the fourth one, if you take, this is the value, right? What direction? Upward direction. This is positive, so you take it in upward direction. Upward direction. Then you come to 2. What's the direction? Towards left. Towards left. Here value is minus. Value is minus. You take towards right. Then you take towards right. The value is 0.0096. Now you come to the third one. What is the direction? Downward. Here positive. So the same direction you take. Same direction you take. This is a couple. Now we have taken 4 couples. 1, 2, 3, 4 couples you have taken. It is not closing. What is the meaning? This is unbalanced force. This is a unbalanced force. You measure the distance, multiply with the scale, and also you multiply with omega square, because we have taken omega square as a common. That couple divided by omega square only we have taken. So you measure the value, multiply with the scale, and multiply with omega square. That will be the unbalanced primary couple. Unbalanced primary couple. Now you see, primary unbalanced forces, there is no primary unbalanced force. All are balanced properly. As far as primary couple is concerned, you measure the value, measure the distance, multiply with scale and omega square. That will give the couple. That will give the couple. This is unbalanced primary couple. Now you come to the secondary force. Now we are going to draw the secondary force and couple. Now these are all the forces. These are all the secondary forces. What is the difference between the primary force and secondary force? Here in say primary there is no n, but here you have to divide by n. Divide by n. This value divided by n, and angle is, instead of theta you have to take 2 theta. This angle you have to take. That is the difference between the primary and secondary. So this is primary secondary couple. Actually this is primary couple. Using primary couple only we have to draw. Then finally you have to multiply, divide by 1 by n. Divide by n or multiply by 1 by n. So that will give the secondary. So now the forces we are taking primary and couple also primary, but the angle is 2 theta we are taking. Finally you divide that value by n, right? Right. Here this is a force for cylinder 1. This is the what force? What is the angle? This is secondary. That is 0. That is 0. So now you take, this is a origin. This is a point O. So this is 0.12. This is 0.12, and this is angle is 0. So this will be the value. This is 0.12. This is a direction. What it represents? This represents the secondary force of cylinder 1. Force of cylinder 1. So this is the force of cylinder 1. Now as we taken in the previous case, you take second, you take 4. You take 4. What's the direction? It is towards left. Towards left. What is the angle for 4? You take the angle. It is 180 degree. 180 degree means what? It is 0 degree means towards right. 180 degree means towards left. So from this point, it will come to again the same point. What is this? This is 4. What is the distance? What is the value? 0.12. Now it is coming to here. As we taken in the last, you take now you take the 2. You take the 2. What is the angle? 360. 360 means it is 0 degree. Then this point to this point. The value same value. Direction is this. The say two second one. The direction is this. 360 degree. And now if we reach this point, now you take the 3. What's the direction? Towards left. Here you can take the angle. This is 180 degree. 180 degree means towards left. Now we are starting from this point towards left, the same distance. So this is a starting point. Again, it is ending with the same point. Actually, all must coincide. Here it is given. From one is starting from here, this point to this point. 4 is starting from this point to this point. Then 2 is from this point to this point. And finally, 3 is from this point to this point. It is coming to the same point. So what is the meaning? Here there is no unbalanced secondary force. Unbalanced secondary force. The polygon started at this point, ended at this point. There is no unbalanced secondary force. Now we are going to draw the unbalanced couple polygon for secondary couple. So now we are starting from this point. Starting from this point. So now you take the couple of the secondary couple. For one, you take. What is the direction? 0. 0 means towards right. But here the value is minus. You take towards left. So this represents this one. This represents this one towards left. Now you take the 4. Now you take the 4. Any order you can take, no problem. You will get the same answer. But we have followed the same order in the primary force and couple. The same one we are following here also. Now you take the 4th one. 4th one, what is the direction? Secondary direction 180 degree. 180 degree means towards left. What is the magnitude? 0.00288 towards left. Then you take the second one. Second one is minus 0.0096. What is the angle? 360 degree. 360 means towards right. But here the value is minus. So again you take towards left. This represents the second. Then this is 3. What's the direction? 180 degree. 180 degree means towards left. Towards left. The value is 0.0096. So the polygon started at this point, ended at this point. It is not closed. It is not closed. Then this is the total distance. The total distance. This is the unbalanced couple. Secondary unbalanced couple. You measure the distance. You measure the distance. What you have to do? You put this distance multiplied by omega square. Actually, this value is for primary couple. Value correspond to primary couple. Then, if you want to calculate the secondary, you you multiply by 1 by n or divide by n. That will give you the secondary unbalanced couple. Now see, secondary force. Here there is no unbalanced secondary force. Unbalanced couple, you measure the distance, multiply with the scale, and multiply with omega square and divide by n. So that will give the secondary unbalanced couple in this engine. So as far as this problem is concerned, when identical cylinders, identical 4 cylinders are at an angle of 90 degree, and firing order is 1423, there is no primary force and secondary force, but there are unbalanced primary couple and secondary couple. You can check with different firing order. When firing order is changed, how the engine is balanced. You can try. You can do many iterations. Which order is best, you can select. No problem. Right? This is for one order. Now we are going to see another problem. This is also 4-cylinder engine. This is also 4-cylinder engine. It's a 4-cylinder inline engine. 4-cylinder inline engine has two outer cranks placed at 120 degree. Outer cranks. For example, first crank, second crank, third crank, and fourth crank. So this is 1, 2, 3, 4. There are 4 engines. This is first engine. This is fourth engine. The angle, crank angle difference between the first cylinder and fourth cylinder is 120 degree. 120 degree. Then you have to draw like this. So this is first cylinder. This is 90. So it is like this. So this is the fourth cylinder. This is first cylinder. The has two outer cranks placed at 120 degree apart. 120 degree apart. And their individual reciprocating masses are 200 kg. 200 kg. That is M1 is equal to M4 is equal to 200 kg. Reciprocating mass weight is 200 kg. The 2 and 3 are not given. 2 and 3 are not given. In the previous problem, all engine are having the equal reciprocating mass. But here in this problem, 1 and 4 are given, 2 and 3 are not given. The distance between the cranks are 200 millimeter, 600 millimeter, and 500 millimeter respectively. The distance between the cranks. Distance between the cranks. You take this distance, and this distance are given. In the previous problem, all are same. But here it is not like that. 200, 600, 500 respectively. This distance, and this distance are not same. 200, 600, and 500 respectively. The crank radius is 300 millimeter. All cranks are having 300 millimeter radius. That is, R is equal to 300, and the length of the connecting rod L is equal to 1200 millimeter. The crank rotates at 240 rpm. N is equal to 240 rpm. If the engine is to be completely primary balanced, what is told? The engine is to be completely primary balanced. Primary force is completely balanced. Primary couple is also balanced. Find the reciprocating masses and relative angular position for each of the inner crank. And also find the magnitude of secondary unbalanced force. So in this problem, there are 4 cylinders. The crank angle between the 1 cylinder 1 and 4 is given. 2 and 3 are not given. Similarly, mass of 1 and 4 are given, but mass of 2 and 3 are not given. So you have to find the value of M2 theta 2, M3 theta 3. So these are the values you have to find. How to find? Assuming that the engine is to be completely primary balance. That is, all primary, the primary force is balanced, primary couple is balanced. By assuming that, you find the value of M2 and theta 2, M3 theta 3, and finally check what is a secondary unbalanced force. This is a given problem. Now we will discuss. So there are 4 engines. As I told, 1, 2, 3, 4. The distance between 1 and 2 is 200 millimeter. 2 and 3 is 600 millimeter. 3 and 4 is 500 millimeter. All are not same, different, right? Now M1 is known, that is 200 kg. M4 is known, that is 200 kg. That is 200 kg. But we don't know M2 and M3 are not known. But radius of the crank, all are same. All are same. It is given. Now you find the MR, that is centrifugal force divided by omega square. You multiply this one and this one, mass and radius, this value. These two you must multiply, you will get this. These two you multiply, you will get this. These two you multiply, you will get this, right? So now distances. We are taking this as a reference. Why we are taking this as a reference? In the centrifugal force, there are 2 unknowns. You have to bring anyone to 0 in couple. Then you have to take distance. You have to take reference as a 2 or 3. Anyone you can take reference. Now we are taking this as a reference. 2 as a this as a reference, right? So if you take this as a reference, distance is equal to 0. And what is the distance for 1? Minus 200. It is left side. So it is given in meter. Minus 0.2. This is 600. 0.6. So the crank 4 is 600 plus 500. 1100. That is 1.1 meters. Now you multiply the centrifugal force and the distance. 60 into 0.2. This value. This into 0, 0. This into 0.6, 0.18 M3. And 60 into 1.1, 66. So in this couple, only one unknown. If you see in the force, there are two unknowns, but in couple, only one unknown. Now, theta. The crank 1 is 0, crank 4 is 120 degree. Theta 2 and theta 3 are not known. And secondary crank, you multiply this value with 2. 2 into 0, 0. 2 into theta 2, 2 theta 2. 2 into theta 3, 2 theta 3. And 2 into 120, 240. Now you have to draw primary force and primary couple, and you have to find the M2, M3, theta 3, and theta 4. First, you draw couple polygon, primary couple polygon, because here in this only one unknown. Here there are two unknowns. In the force, there are two unknowns. So you draw the couple polygon and find the value of M3 and theta 3. Then you draw force polygon and you find the M2 and theta 2. So now, after drawing the first polygon and couple polygon, you will be knowing M2, theta 2, M3, theta 3. Then you can find secondary unbalanced force. Right. So this is a table. This is a table. Now we have the couple. We have the couple and angular positions. Angular position. Using this, you draw the couple polygon. So first you take one. What is angle? 0 degree. 0 degree means towards right. Towards right. But here it is minus. Here minus. You have to draw opposite. This is a starting point. Value is minus 12. You take some scale towards left. So this value is couple of the first cylinder. Next, this is unknown. This is unknown. This is 0. You leave it. This is unknown. Now you come to 66. What's the direction? 120 degree. 120 degree means this is a direction. This is a direction. Along this direction, value is 66. You draw a vector. It comes to this point. So now the B dash, O dash, this is not closed. The polygon is not closed. So what is this? This will be equal to this value. This will be equal to this value. What is the direction? This will be the direction. This will be direction. Okay. So in the primary crank position, parallel to this, here you draw this line. Parallel to this, you draw this line and measure the angle. This is 310 degree. What is this? This is the angular position of crank 3. Angular position of crank 3. Now you got theta 3. Now you measure the distance from this point to this point. You measure the distance. That is, you will get some value. That will be equal to this value. That is, that value is equal to 0.18 M3. From this, you can find the value of M3. But here, when you put the value, what you have to do? You have to multiply with scale. You measure the distance and multiply with scale. And you find the value of M3. So now, by drawing the first couple polygon, we have calculated M3 and theta 3. Now you substitute the value here. Now only unknown is M2 and theta 2. Now you draw the first polygon. In the first polygon, first you take 60. From this point to this point. For the first one, angle is 0 degree and magnitude is 60. Some scale, you take this. Some scale from this point to this point. Next, you take the fourth one. What's the magnitude? Fourth one, 60. What's the direction? 120 degree. This is the direction. So along the 120 degree, you take 60. Now you got this point. Now you take the third one, this one. Already we have calculated the value of M3. You multiply M3 with 0.3, you will get some magnitude. What's the direction? This direction. That is 310 degree. This is already you have calculated. This is 310 degree, right? The same direction. You multiply M3 and get the value. This is a direction. Now, this is a starting point. This is a end point. The polygon is not closed. So there is an unbalanced force. The polygon is not closed. Then you measure the distance. That will be equal to this value. 0.3 into M2. You measure the distance, multiply with scale, and equate with 0.3 M2. You can calculate the value of M2. What is the direction of the force? This is the direction of the force. So here you mark. So now you calculated M2 and theta 2. Now we can draw the secondary force polygon to calculate the secondary force. Secondary force. Here the value of M3 is equal to 427.7 kg. M2 is equal to 400 kg. Direction is this. This direction is this. 310 degree and 158 degree. Now the same table. We know M2 value substitute. M3 value substitute. Theta 2 value substitute. Theta 3 value substitute. You will get theta 2, theta 3, and this value also now. We have to calculate only unbalanced primary force. That is what unbalanced secondary force. That's what you are asked to calculate. Now, what is the direction for secondary? 0 degree for 60. So this is the starting point. 0 degree means horizontal. So you mark the 60, right? Now you take. We have taken the same order. Now you take 2. Now you take 2. What is the direction of 2? This is the direction of 2. Already we have calculated the direction of 2. This is the direction of 3. Okay. This is the direction of 2. Now we are taking the 116. 116. That is here. That is primary crank. This is primary crank. 2 primary crank is how much it is? 150 theta 150 degree. For secondary, you have to multiply with 2. That is 158 into 2. 158 into 2. Then this will be the position. 316. 316. 158 into 2, 316. This is the direction. This is secondary crank direction. This is 316. 316. Similarly, theta 3 is how much? Theta 3 is 310. 310. So multiply with 2. Multiply with 2. 310 into 2. So 620. 620. That will be equal to 620. That is 360. One round, then second round. 360 minus 620. So you will get this value. This is 620. So this is a position of 3. This is a position of 3. What is the position of 4? That is 120 into 2, 240. This is a position of 4. Now, we have drawn for first cylinder, secondary force. Now you take the 2, second one. 0.3 into M2, put. You will get some value. How much value? It is 116. 116. So what is the direction? This is the direction. So along the direction you draw. Now the third one. Now the third one, it is 620. That is this direction. This direction. You multiply with M3, you get the value. That will be 125. 125. This direction. You got to draw. Then fourth one. What's the direction? This one. What is the value? 60. You draw. So now this is a starting point. This is an end point. This is unbalanced. This is unbalanced. You measure the distance. You measure the distance. Multiply with the scale. Multiply with omega square divided by n. Why divided by n? It's a secondary force. Secondary force. While calculating couple, we have not concluded n value. We have not included n value. So after calculating this, you divide by n. That will give the secondary unbalanced force. Secondary, you measure the distance, multiply the scale, multiply the omega square, and divide by n. Now you can see. See, this is that distance 55. Multiply with scale, omega square divided by m. So this will be the unbalanced force. This will be the unbalanced force. So here there are number of variables are there. Number of variables are there. What are the variables you can vary? In case of engine, you can vary the mass, you can vary the radius, you can vary the theta and firing order by doing a lot of iterations by permutation combination. You can try to find which will be the most effective, that is unbalanced force reduces, which condition, which combination will give the minimum unbalanced force. That will be nice, so that it will reduce the vibration and unnecessary noise. So here we have taken some dimensions, some mass, some radius, and some theta value and firing order. You can vary this. You can varying this according to a requirement. That is up to you. You vary and you find the perfect combination that will give minimum unbalanced forces and couples. You can try.